What is up, everybody? Let's see. Let me make sure I'm all good here. Apologize for the really long wait. So during the break, I decided to just take some time to myself, to be honest, work on my own stuff. I did end up finishing the project I was working on before, which was a great feeling because I've been working on that for over a year. So, coders. Ooh. Make sure everything's good here. Okay, I don't know why that's going through my speakers, but it's all good. Yeah, weird that was going through my speakers, but okay. Alright. Anywho. Pull up live chat. Take a look at it every once in a while. Okay. So, alright, since we got a few minutes before I was supposed to actually start stream, I just had to make sure that the stream was good. So I finished my TFTP application. That's on my GitHub, which I believe is in my YouTube bio, so you can take a look at that if you want. I actually haven't done as much over the break as I wanted to. Mainly because the holidays were actually a lot more busy than I thought they would be, and so I was just like, okay, I'm not gonna be doing like little tiny streams where I'm barely doing anything, you know. So, anywho, so today we're gonna be doing a CTF challenge off of a platform called stacksmash.io. If you guys know Low Level Learning, or just Low Level, he does cybersecurity videos, and he teaches everything from binary exploitation, different techniques for that, overflow exploitation, stack and heap. He made a platform called stacksmash.io, and I was part of the beta testers for it, and it's now open release, so you can check that out too if you want. I would highly recommend it, actually, because I've been making a lot of good progress, more so than I have before. And I've done other platforms like Hack the Box, Try Hack Me, a couple others. And while they're good platforms for challenges, I don't believe they really teach exactly what's going on and what certain parts of assembly mean and disassembled code, which I mean, honestly, I think part of that is just me. I think that was a skill issue, because I also haven't done cybersecurity stuff in a really long time. So, but yeah, I already did a few challenges. They're right here. I really like the assembly challenges, actually, but my favorite are the pwn challenges. So the one we're going to be working on today is going to be the Ret2libc technique when you're dealing with buffer overflows. So I already have something built out here. I have a Python script that generates a payload, and I also have a script that interacts with the process using pwn tools. Currently, I found out where to. So I guess I should probably explain what the Ret2libc technique is. So what Ret2libc is essentially for binaries that you're trying to make an exploit for. They could have what's called the NX flag, the non-executable stack flag, which essentially prevents you from writing shellcode into the overflow and executing things on the stack, right? So instead, what Ret2libc does is it allows you to write the address of functions that are linked in the binary that allow you to take advantage of it and exploit that as well. So as you can see from the script here, we have the system call, the address of the system call, the address of the exit function, which allows us to stop the program gracefully or exit gracefully. And then we had to locate the string that we need to pass into the system call that's also linked into the libc library by default. So if we fire up GDB or pwn debug, I use pwn debug. Some people use pwn, or some people use GDB, other people use Jeff. You can use combination too. But if we get this started right here, first we need to disable ASLR, and then we need to set follow fork mode to parent. So what follow fork mode is essentially whenever a function that calls fork the program executes, typically by default it'll follow the child process, I believe. If we so set debugger response to a program call of fork or vfork. It can be parent, where the original process is debugged after a fork, or child, the new process is debugged. By default, the debugger will follow the parent process. So that's actually not true. I had to set this precisely because it wasn't continuing the debugging process after the call. So had to set that so it would continue debugging the parent process. Let's break our function, and then actually if I get turn on the music too loud. There we go. Okay. I also have binary ninja. So if I get that fired up, I can also show y'all where I even know where to get the function. So the high level disassembly intermediate language, you can see right here there's a function called vulnerable function. Obviously that's the function we want to exploit. You can also in pwn debug do info function, and that'll give you it'll give you what calls are in the source file. So you can see here as well, vulnerable function, and send that to the background. Let's go ahead and just run it with our payload. Actually, did I? Okay, yeah, I did generate the most recent one. Okay. So, oh, right there. The call I just passed, a system call, that was the call to, it was literally the call to system. And before, I was having trouble continuing the debugging process for this because it would just fork off and it wouldn't be able to debug the child process, I believe. Like, it was attempting to debug the child process and it wasn't able to. But after we set that option, now we're finally able to continue debugging. So had to take a sip of water there. Alright, so we step through here, next call to gets. That's what we are trying to exploit right there. After we do that, we can see that our input has overflowed into the stack, as well as some registers like EBP, for example. Do next call again. You can see that our exploit overwrote the return address for vulnerable function to be that of system. We were passing /bin/shell as the argument, and then we also have the return address for our call to system, and it exits gracefully. So one of the problems that I am having now is, I think with how the exploit is right now, because it's not working. Like I go through the debugger and it executes the shell. So if we do this, if we go to here, I don't know if y'all can see that, but hey, hold on. Okay, it could be oh, actually no, that's expected behavior because we set that option before, right? So now when we execute the call to system, the system call, it's gonna exit and we're not gonna see that a shell spawn. However, if we restart it and we don't set the flag, okay, yeah, let's do that. So first we're gonna same thing, set disable randomization and set fork mode parent so we can follow the program after the call to gets. Vulnerable function, run it with our payload. Okay, alright. Next call. Okay, now if we set follow fork mode child and we finish this, yeah, there you go. So right here now we can see that the Ret2libc process is still active. If we run it again, it executes a program, and we can see dash is spawned right there, right? So it does work. Give me a second, I gotta answer these texts. Alright, so yeah, so like I was saying, it works, but whenever we try to take advantage of the actual exploit, so there's a little technique where you can cat your payload, pipe it into the program, and what this will do is so this is what's called sub-processes, or processing. And essentially what we did right here, this will be evaluated in a subshell, and because by default this makes the standard output, well, just this by itself evaluates and it serves to be the standard output right here, and then it gets piped into the program. So we have the first part where it'll concatenate our payload, and then cat by itself will read from standard input for the standard output of a process. And so that allows us to keep the standard input open for the program, so then we can once we gain access to a shell, we can type in commands and stuff. However, besides the broken pipe, yeah, so typically what I've been experiencing so far is we get a broken pipe error, and then we get a seg fault, and I believe that it is for multiple reasons. So first, right, like we saw in the program, there's a system call which will execute the command given, which right here, echo enter your input. That's not the problem. The problem right here is gets, right? So I believe, so because it's getting input, you have to provide a new line for it to continue. So at first I was like, okay, well, I'll just type in, or I'll just add a new line into my input and we'll be good. But that's clearly not the case. Here's our new line. Get a broken pipe. You can try putting it directly into the payload. Get that, same thing, broken pipe. That's a new, actually, floating point exception. I haven't had that before. It probably has something to do with the fact that we overflowed quite a bit in the stack. Might have something to do with that. Could be. So my current theory is that because not only did we get floating point exception, by the way, when we added the new line, we also got an illegal hardware instruction. So my theory is that it's reading whatever's after our stuff, and it is failing. So I want to try and see if I can just add some no ops and do it that way. But I don't know the no op instruction for 32-bit architecture, so let's do this. Can make a valid program, assembly program. Start Intel syntax prefix. We'll do text op. No. Pretty sure that's a valid program right there. Then we can compile it. 32-bit architecture, no standard lib. We're gonna do just main. This. Okay, so it took it. Oh, we also just want the text section. You want to observe that. So what we can do here, gotta review because I haven't used object copy in a bit. So only sections, that's one argument we need. What else? There was a type option, I believe. I just want it to be binary. Or maybe that's it. Okay, I guess that's it. I thought there was something else that I needed to add as an option. Whatever, it's fine. Okay, so what is it? Dash J, alright. Object copy dash J. We're gonna keep the text section into main text, and then this will be our file. Main text message file. I guess the file we're gonna. Oh. Okay. Not sure why I removed the file. That's weird. It's the same thing. You're supposed to pass it the... Yeah, okay. Empty loadable segment. Okay, we don't care about that. Okay, there we go. Hex 90 is the no-op instruction for the 32-bit architecture. So let's try appending. Shoot, I don't know. A few of those, I guess. Let's do 4. See what that gives us. Generate the payload. Make sure we're good on that. Yep. And just cat. No, same thing. Let's see if maybe we do have to add a new line. Which I don't think is the case, to be honest. It might just be tripping. Same thing. Okay. Well, I guess we're just gonna have to debug it, because I don't know what could be going wrong, to be completely honest. I'm not sure. And I know that the syntax of my command is correct. My initial thought was that the call to gets the payload input into it, but then because it's not past a new line, it like the next call to cat, which is just from standard input, press enter, send a new line, gets out of the call to gets, and then it continues to the system call. But because the system call forks, I'm not sure if it inherits standard input. So let's check that first. We can actually just pull it up right here. That's not very descriptive. That's because it's... Okay, guess we have to look it online. society, the child does not inherit memory logs. Yeah. Okay. Okay. The parent is replicated in the child, which this also implies standard input. Open file descriptors, yep, so standard input, okay. Okay. See, that's the thing, I don't know if it might have something to do with not really sure, to be honest. Well, if it duplicates the file descriptors, then it shouldn't be an issue. But I feel like the issue is the call to gets, because we're sending. It has something to do with that, I think. But let's go ahead and go through, debug it. It'd probably be better if we could supply different input into the system call, to be honest, which we technically can locally to test it. Can do like can do it through environment variables. Well, let's just follow the program for now. Flushes standard output. That call to flush might be what's getting us. Maybe, I'm not sure. No, that's not what's getting us. Let's was passed. Payload, incomplete sequence. No. Recognize the first thing as a space. That's normal. Just look at it. Okay, there we go. And just look at the hex of that. Yeah, let's look at the hex. I think it's like 90 or something. A B, A C. Yep. Okay, this is our payload. F7DC, F820, F820, yep. Exit address. Up next, F7DB, C5D0. Yep. Location of the string. 7F58D F2. And then we have our BF. A null byte and BF. I don't even think that exists here. Yeah, no, it doesn't. Alright, well, let's keep following the program. I wonder if we should have followed that all the way through. Maybe. I mean, there's no protections on this binary, so let's rerun it. it right there. Move X1, push ESI. Wow, that was the, okay, that was our, yeah, I set it to 0, push EBX, X1, I believe this is just setting up everything. Okay, I think it's about to leave the function. Pop EBX. Pop ESI. Pop EDI. Pop EBP. Ret. Well, nothing went wrong. So nothing's wrong with the stuff we just wrote, which is odd. Yeah, I don't know. I'm not really sure. I guess that's got to be something we're doing then. Let's look something up. Because what exactly is a broken pipe? Right. Yeah. Okay, process receives a SIG pipe when it attempts to write to a pipe or socket of type sock stream that has no reader left. So So that means the Ret2libc binary is okay, that's interesting. So maybe so a broken pipe is the right of what EF is to the reader. Okay. Let's try something then. So we don't need that. Actually, let's keep that in there. Instead, let's try this. Pipe to standard output to Ret2libc. But we want to find a way to redirect the child standard input, which is duplicated at that system call 2. Because I think what's happening is that to be honest with you, I'm not 100% sure. It has something to do with the fact that we're using process substitution and our second call to cat is getting messed up somehow. Like the process, the Ret2libc process is closing out before we can provide input, I guess. We're still getting a segmentation fault though, which is confusing to me. And an illegal hardware instruction? Yeah, it doesn't make any sense. I did notice that EBP is still so EBP still has our stuff in it. So that could be part of the reason why. RSI and RDI also had. Well, they get overwritten by the caller. So we're not the caller, because we're the caller. We're calling the function. And then it cleans up afterwards. I don't know. See, and this error right here is the reason why I thought, oh, maybe I should write in no ops too. But I'm also not entirely sure that's exactly why. Let's follow the program again. Except this time, let's try this, because I'm curious. Oh, I didn't break it. Okay. Oh, yeah, did the thing. See, that's so interesting. That is very interesting. Should get the shell right there. Yeah, I don't think we're directing it properly. still seg faulting too. It's weird because it's seg faulting, but then we put it through the debugger and it's not seg faulting. Doesn't make any sense. Let's try, because we don't, say two, so 4 extra, 80, 76 characters. I wonder if that would work. Nope, still seg faulting. I wonder if it has something to do with, I don't think it would have anything to do with the space. At least I don't think so. I don't know. I was reading yesterday this as well. IO redirection. Oh, look at that. Child processes inherit open file descriptors. I will be right back. Alright, I'm back. I do have to head out though, so I will probably be back later. Maybe. I don't know. Anywho, catch y'all later.